Yeah, good morning, everybody, and welcome to our ERCI webinar on railways and AI topic, Together for Efficient and Smart Mobility. My name is Lutz Hübner from Berlin Partner for Business and Technology. With our regional cluster for transport, mobility, and logistics, we are a member of the European Railway Clusters Initiative, which was founded in 2010 and based in Brussels since 2022 as a legal entity. It covers 18 railway clusters around Europe and represents over 3,600 enterprises, including over 2,300 small and medium-sized enterprises. It is managed by nationally, regionally focused clusters, and our major work is priority for small and medium-sized enterprises to give them visibility on European level due to partner matchmaking, due to R&D projects, and to other supporting instruments. We are dealing with innovation topics which might be interesting also for the railway sector, like cybersecurity, multimodal logistics, green and sustainable mobility, human factors, and other topics. And some of these topics we are focusing in task forces where we try to bring together companies and stakeholders from the different regions to work together in these topics. Then our highlight of ERCI annual highlight are the ERCI Innovation Awards. They have been performed for the 10th time during the InnoTrans and will perform in 11th edition in 2025. And what to say for the moment is sure the awarding ceremony will take place next year during the Expo Ferroviaria in Milan. We are conducting bilateral workshops and webinars in order also to improve the contact between the stakeholders from the different ERCI regions in order to think about innovative ideas, to get in contact on that, and maybe also to develop joint projects on that. Yeah, our contact data you will find very soon into the chat. And also the questions that you may have to our speakers, you can put them into the chat. I will copy and paste them to a special slide after each presentation, and then I guess we will have a good webinar today. The first both presenters come from Austria. Gerhard Schuster and has over 30 years of experience in software development in various management roles and supports the management of DCCS in strategic issues as executive advisor. Matthias Pur is a machine learning consultant and product owner with over 5 years of experience of expertise in guiding customer projects from inception to deployment in AI, data science, and machine learning domains. We will learn something about anomaly detection in production, and Gerhard and Matthias, the floor is yours.
Thank you. Thank you. You see my screen? Okay, yeah, very welcome from Austria, from Graz. Yeah, a few words about our company. Yeah, we are a software development company with about 340 employees. We are in 7 locations in Germany, Austria, and Bosnia and Herzegovina. And yeah, we have an history of more than 30 years. We see us as a digitalization partner, and we support two sides of digitalization. One is the interaction of your customers with digital services, product enhancements, and so on. And the other side is our internal processes. So we do end-to-end process digitalization. We do data and analytics topics, data warehouses, and so on, and to lead you to a data-driven company. And we do it in a customized way, so we don't have nearly no standard products. So we do customized development. Yes, we don't want to spend much time about definitions and AI principles. We directly jump in some real use cases, and therefore I hand over to my colleague Matthias.
Yeah, thank you, Gerd. So we have done lots of customer projects over the years. Today we want to show you two of them, which nicely project the spectrum of what can happen in AI projects. So from a simple project where the challenges can be solved with existing tools and quite simple algorithms to a project where we really had to customize a deep learning model for our client. So let me dive right in and start with the first project I want to talk about. This was in the area of handling of warranty claims, where we had a customer who did all this handling manually. So they manually processed the customer submissions. And as you can imagine, this is quite time consuming, monotonous, and therefore also error prone. But they had very good data about this whole process. So they really recorded past expert judgment in the sense that they really stored the text of the submissions, some metadata to the text, and that's very important in this case, they also stored the expert decisions. So we really had labels in this case if a warranty claim was approved or rejected by the expert, and we could use this to train a machine learning model. We asked the customer here for a representative data sample, and they were able to provide us with around 10,000 data sets to learn from. And in this case, we were really able to use existing tools to leverage open source solutions, which has a great benefit for the customer that it cuts down on licensing costs. And furthermore, we were able to really quickly go into the implementation here. In the end, we were using a statistical machine learning model for this task, where we have used the classical natural language processing methods to deal with the text and the language parts of this task. And I want to emphasize this here. So it's not always necessary to use a large language model or ChatGPT if you are dealing with text. The big advantage of choosing simpler models, for example, is here that the training time is really, really small. So it took a few minutes on a laptop to train with the 10,000 data sets. And in principle, the model decisions here are explainable since there's just some statistics behind it. And even with the simple ansatz, we got very impressive results. We were able to sort out more than 90% of the irrelevant submissions for our customers. So this greatly reduced the manual work and the time to processing these warranty claims. The second project I want to talk about is in the topic of visual quality assurance. Here we had a customer who wanted to do an optical inspection of mechanical parts in an industrial production process. So you can imagine that you have this conveyor belt, the parts go by, a photo is taken, and then you should decide, is this part okay, or should we rework or do some more work on it? This had some very complex challenges. One, and actually the most challenging here, was the lighting conditions on the shop floor. So this is a customer where they work 24/7 in 3 shifts a day. And the lighting changes constantly depending on weather, windows that are open and closed, people walking by, casting shadows, alarm lights going on somewhere in the distance, stuff like that. So this is really a very, very noisy environment. We have the challenge that the quality of the parts was very high. So ironically, this is a problem for machine learning because we had lots of parts that were IO, in Ordnung in German, which means they were okay, there were no faults in these parts. And because production is already highly optimized, there were not that many parts that were not OK or NIO in the customer language. So there was not a lot of data to learn from. And the third point is we have to integrate this AI solution in the production control on customer side. So there's no use if you have this nice AI solution and you cannot integrate it in the systems that are already running there. We started this project off by evaluating existing AI systems. So the customer had something in use already and was also looking around if something on the market can solve this task. We found out that for all these solutions, you need a lot of AI expert knowledge, and the training of the models is often very cumbersome. And even if you manage to train these models, the results were not really satisfactory most of the time. So that's meant we really had to go back and start from scratch and look for algorithms that were suitable for the task at hand. We started with an extensive research and finally ended up with a recently published algorithm, recently at the start of the project. And this was really performing visual anomaly detection with a deep learning approach. The big advantages here were that we could use this anomaly detection and train only with the IO images. So basically, the AI learns in this ansatz what is a good part and not what is faulty, where are the faults, but it learns how should these parts look like, and it can then recognize if there are any diversions from how it should be. This has the big advantage that it's universally applicable and that we can use it without specifying any errors in advance. We were able to package this stuff in a graphical user interface for our customer so that we could really have this nice solution where the training images were taken automatically as the parts went by on the conveyor belt. Then someone just has to look at all these collected images and decide if they are okay or not. This is something that the people at the customer side can do. They are the domain experts. They know if this should look like that or not, if this is a broken part or not. And everything else happens automatically. So we have automatic training of the models, automatic versioning, so that it's always clear which models and which data were used to make some decisions. So this is all traceable. And the nice part is that you can visually inspect everything. So I already talked about the training images, and you can also see the results. So we have an example here on the slide. Our algorithm really highlights on the pictures where it thinks that something is wrong, which is a big plus because you do not have to look in the picture yourself and decide where on the part is the faulty area. And overall, this is a really nice solution because it does not need any AI skills on the side of the end user. We were also able to integrate this completely in the production control at customer side. So this really runs. We get the request from the control to now take a picture and analyze the part. We do that and we send back the result. So then it's decided, okay, if this is okay, it can go on. If not, it will be sent to rework. What we found out in this project is that this AI approach is really able to completely handle these challenging lighting conditions. It takes around 100 training images, which should be representative of the different lighting conditions that can occur. But if you have that, then it's no problem to really start with this ansatz. And we found that we have no wrongly classified stuff that is NEO because of lighting, and that should actually be classified as IO. We got a lot of positive user feedback that the solution is very flexible and user-friendly. As I mentioned before, there's very low training effort. In principle, all you have to do is to erase the training images that show bad parts or faulty parts. You do not have to specify any of these defects that can occur in advance. This is a big plus because it's often not clear what can go wrong. And even if it's clear, it's hard to specify it and list it all. So big plus here. And as I said before, so this is all explainable. So people can look at the images and the AI will immediately highlight where something happened. And you can check for yourself which part of the image was responsible for the classification. This has a big benefit for our customer in this case, because this greatly reduced the downstream costs. The main problem here was actually that with the existing solution before, there was a lot of rework done unnecessarily, because parts were falsely classified as NIO because of the lighting conditions mainly. And one more point is that we really could do this without any special hardware. So we do not need a high resolution camera or anything like that. It can be done with standard hardware and standard industrial cameras. What we see here is a simple training example. So this is a setup that we have in our office where we train with some parts. You see here a sample of training images. These are really just 8 images as a sample of all the training images we used. As I said before, you need around 100 usually. And this is not the same image. If you look closely, you will see there are differences in the shadowing and also sometimes metal glares and stuff like that. And we can now use this, train the AI, and check how it does if we have some common errors. So one thing that can happen quite often is that parts are missing. And as you can see, this is found immediately by our AI. We can have also smaller parts defective, like a small tear in the sealing ring. This is also found immediately and marked. Or even stuff that has nothing to do with the part itself, like loose parts that fell from somewhere on the conveyor belt, and they are also identified and marked on the image. Or even a combination of faults and mistakes, like torn and displaced sealing ring, which will also be displayed here and marked clearly where in the image something went wrong. Okay, so and with this short presentation of how this algorithm works, I give back to Gerhard for the conclusion of our presentation.
Yes, let's come to a conclusion, or let's say some kind of lessons learned of the time about the last 5 years where we are doing AI projects. So we try to sum that up in 4 slides. Yeah, one learning is especially if you're searching for AI use cases, you should ask the right questions. If you ask the wrong questions, it often leads to use cases that have little benefit. They sometimes end as a showcase or a POC, but they never go into production. AI is nowadays a very flexible tool. As I call it sometimes the Swiss knife of digitalization. So is it very flexible? You can use it on different situations. So you should ask, what can I do with AI? Or which problem can AI solve? You should just ask, what are the real challenges? What are the problems I have? And then you can ask, and how can AI help me? Then you work on the real problems. AI can solve real problems, and you should not do it just to use AI. And yeah, we learned that, and we have workshop format where I especially ask these right questions and really search for the real problems to solve. The next very important thing is don't look for a 100% solution that replaces people entirely. 100% solutions that they're very difficult to reach, and they only achievable with a great expense. I often compare this with this 5 levels of autonomous driving. Everybody is speaking about level 5, but level 5 is very complex and maybe not reachable within the next future. But even if you think of a car in adaptive cruise control or blind spot detector, they bring a lot of add-on, a lot of added value, and then they are somewhere in level 2. So you should always ask, well, what is the minimal level that I have to reach to give added value? Sometimes it's 80%, sometimes 50%, but we are searching for added value. And then if you have that, then your solution will be successful. And And you should see AI as an assistance function and not try to support. It should support people, and it should not replace it. That's also a big topic in the EU AI Act. So this is human in the loop is very important. Humans should always be the final controlling authority. Yeah, the next important thing is do not underestimate the overall project. On the right, you see a graphic. It's from a paper from Google. It's they analyzed a lot of machine learning projects on the efforts, and you see the orange part here is the effort for the real machine learning code. The orange edged area has something to do with data, and therefore you need data experts and machine learning experts. But all other stuff are topics where you need software developers, you need integration experts, you need infrastructure experts. But if you don't do that, your project will not work. Especially integration in your system landscape is crucial for success. So you always need all of this to be successful. Especially operating topics are very important. So the final learning is don't reinvent the wheel. Every year, billions of euros or dollars are invested in AI research worldwide. And especially if you're a small company, and there is no need to do research on your own. There are universities, there are research companies, there are big companies doing research. You find a lot of in the internet. So use these published things. You will find tons of that. There are solutions for the most problems. You just have to find that. That's also not easy because there's a lot of. So you just need a good expert team or a partner who does that for you. You need some scientific background to understand all these scientific papers. This is also not easy to get an overview because there is a lot of stuff there. And you need some good abstraction skills and creativity to take these solutions and make your solution out of it. And you also need some courage to try things out. But if you do that, then you will be successful and you don't need a lot of money to find solutions for your problems. Yeah, that was our final lessons learned. So yeah, we have finished with our lecture. We have some time to answer your questions. So I will hand over to Mr. Hübner.
Yeah, thank you, Gerhard Schuster. Thank you, Matthias Pur. And just coming back to our slides with the questions, and there are some questions indeed. And the first one is, how long does it typically take for an AI project to be implemented? Who will answer?
I can answer, maybe Matthias can add something. Yeah, the right answer is it depends. But yeah, normally we start with a POC and try out if the idea really works. That is normally, if it's not too complex, done in, say 2 or 3 weeks. Then you know, is your idea working or not? And then you can decide, do you want to make a real project out of that, then normally it takes another, it then depends on the integration, how difficult is the integration in your system landscape and how much normal programming effort is there. But typically in say 50 days, you can do a lot of, in time it's 2 or 3 months.
Yeah, the next one is what impact does the EU AI Act have on AI projects and how to prepare?
Yeah, EU AI Act is an important thing, and it's very new. The important thing is to there are these levels where decide which what is allowed and what is not allowed, and especially things where there is no people in the loop. We have to be very careful about that. So this people in the loop topic is very important to make assistance with AI, and don't make completely automated systems, because if they make a failure, then it could be a problem. So you have to think about that when you analyze your use cases. Are they crucial for some human life and so on? Then it's forbidden for the EU Act. So if you have a life-saving machine, then it's not allowed to use AI for if that could be a big problem in the machine.
You presented the do's and don'ts in AI projects by the end of your presentations, and are there additional reasons that AI projects fail?
Yeah, also start with Matthias. It's or maybe Matthias could start there.
Yeah, I think there are a variety of reasons. One thing that comes up again and again is that this, the context of this whole project. So if you start a project with AI just to do AI, then this very often does lead nowhere. This we already mentioned, you should probably not go that way. Another thing is the data quality, which is really essential, especially for machine learning. So if the information we want to learn is not really there in the data, if the data is too dirty, too noisy, then this can really be a huge challenge for the project. And in some cases, this is also the expectation. So we also heard this from Gerhard. You probably should not expect this to be 100% solution. Try to go in and think what can already help me. Is it already a big help for me? Do I save money already if it's 70% accurate, and going with that mindset? So I think also the wrong mindset might sometimes be a problem.
Yeah, another question is from one of the participants, and he said, I understand that data are essential. Big data is not a figure. How to define the quantity of needed data?
Yeah, that's a big depends. So I think a general rule of thumb is the more complex the model you are using, the more data you need. We had an example here with statistical models that can also work, and in some cases they are good enough to bring results. And in that case, it's mostly that you do not need that much data. You can, in some cases, also rely on pre-trained models that you do not have to train from scratch. And you can also get by with not that much data. But if you really have a unique use case and need to train a complex model from the ground up, then usually we will need lots of data.
Yeah.
What lots is really depends on your use case.
Yeah. What about the issue of these data availability? Are you often struggling with this in your projects, or are all data that you need are normally available?
No, this is actually a point that we clarified during the proof of concept phase of the project. So there might be reasons why you cannot use the data for your AI project. Might have something to do with data protection rules, governance. secrets that are not easily usable for training machine learning models. So company secrets, customer secrets. Yeah, this is an issue and this has to be addressed early on. So if you do not want to start this project and 3 months in discover that you cannot really use the data you would need.
Yeah, that means you can you not use instead of real data simulated data, or
in some cases, yes, but
yeah.
this might greatly reduce the quality of the AI models and
Yeah.
sometimes.
That leads us to this last question, which is indicated in the slide. How far is it possible to automate the workflow from data pool to finished model? It was a special question to Gerhard from this participant.
From a technical perspective, it's no problem. You can do that. It's more the question: how can you test then the model if it works anymore? So it depends on the use case. In some use cases, it's no problem. You can just automate that. But if there's that risk that the new data changes the model and then it's not working anymore, then yeah, that's the problem. How do we test that? Then you can make some automated tests. So like within software development, you work test cases and automatically test it. And if the test not works, then you don't deploy it. It's a solution for that. But you have to carefully discuss that in the project, if that makes sense, or do you have these test cases and what happens if the model does not work anymore?
But in general, it's not really technical reasons that make it impossible to do this 100% automation, but some others like regulatory or accountability reasons that in the end, somebody has to click deploy model to be accountable for the new results, stuff like that.
Yeah, I see no more questions for the moment in the chat, but you are still invited to raise your questions also for the first presentation. I have a very last question. What is the relationship of the work of your company with the railway sector? Are there already existing projects with customers from the railway sector and so on?
Don't remember it's real that the railway sector, but we are in the industrial sector, very common production, and automotive is one of the area where there's a lot of customers. Maybe there's some of them are also make products for the railway sector, but I don't remember at the moment.
Yeah, but normally in this domain, working with artificial intelligence and data handling, I guess it is not quite important to which sector you are connected with, because you are providing the basic methods of AI and other advanced technologies in order to be applicated in different sectors, isn't it?
Yes, we are universal from our thinking and from how we do it. It always is. Yeah, it's useful if you have some know-how, but production is somewhere similar in different sectors. And in some AI topics don't depend on the real use case. It depends on the data. You must understand the data. You must understand that the use case behind that and the processes, and that we normally are able to understand process very, very fast and learn new processes.
Yeah, thank you very much. And if there is no urgent question for the moment, if there is one, then please raise your hand and open your micro and ask. And thank you very much for this interesting general presentation on AI projects, of the do's and don'ts, of the opportunities and of the risks. I think that is a very good thing aware the railway sector in order how to handle with AI in the future. And on our participants, I think there are some of them that might be interesting to work with AI in the future. And there is just one remark from the chat. I just put it into the slide. There is one guy from DTEC, and he offers a wayside vision gate for train monitoring with AI. I think very interesting, and also the contact data of you are in the slides. Maybe you could add your contact data also into the chat so that maybe an interesting discussion could be taken during or immediately after the webinar. I guess that is the best solution that we as ERCI are able to provide with the help of those webinars. So thank you very much, and we are early and good to be so. So we had much time to follow our next presentation. It comes from Sid Hinrichs from Pointly, and Sid manages the project operations at Pointly, an AI company from Berlin that focuses on the analysis of the 3D point clouds. Yeah, that is a very short introduction, and Sid, the floor is yours.
Thanks a lot, Lutz, and good morning, everyone. I'm sharing my screen. And yeah, today I'm here for the first time at this cluster, so I'm happy to have this opportunity to present some of the technologies that we apply. We are a young company. Pointly is a spin-off from Sapper & Sapper, a data science consulting company. So that's where our background is in data science and training AI models. And we are specialized on the processing and applying of AI models on 3D point clouds. I want to share a quick quote from one of our partners. And he once said, 90% of our clients don't want the point clouds. And that quote really stuck with me because that partner, they are producing laser scanners, which are essentially creating 3D point clouds. So of course you want to wonder what do they want if they do not want the point clouds. In the end, point clouds are just a vehicle to create further data products like digital elevation models, tree inventories, or any kind of 3D models, map layers, or meshes. And point clouds themselves, they are quite a bulky format, very compute intensive, not easy to handle. So we have large amounts of data with high precision, but we actually just want to extract further information from them typically. So that is something that we have taken ourselves as our task to do. And we have built a cloud platform to support this process. I want to talk a bit about the platform and quickly show some examples of how it can be used. And also then tell a bit more about how we train our AI models and do the classification and vectorization on the point clouds. So the key features to extract data from the initial point clouds for us are classification and vectorization. I will mainly focus on classification in my presentation today, but yeah, maybe first showing 2 short videos to demonstrate what this looks like. So the classification is something that we can also do on the platform manually. So here you see a quick video showing how classification is done with some segment-based approach. So we have different classification tools. We can draw polygons. We can create 3D bounding boxes to do classification. So those are like the classical segmentation tools. But we also have this cluster approach where we can quickly, like with a magic wand, click on an object and a big part of a project will be classified. So it really speeds up this manual classification workflow. The second part on the right side is the vectorization. That's actually a different approach. We can add point features, we can draw polygons around objects, and we can draw polylines. So this is a different approach. We add another layer on top of the point cloud. We do not directly work with points as for the classification, but we create new features which can be exported as their own dimension or data type and can be imported into other tools immediately. And vectors are a very lightweight format in comparison to point clouds, and they can also carry a lot of metadata information like type, length, and a lot of those attributes can be added to each of the vector elements. And now you're wondering what we do as an AI company. Of course, we are going for deep learning automation of those tasks. We have built the platform to also support the manual processes because we need to create training data as well, or sometimes you need to do some amendments. So all of that is possible manually, but our focus is on the automation. And there are many different use cases where we can apply this technology. So I already mentioned like airborne laser scans is like a very typical application. So we work a lot with this kind of data taken by planes on large areas, but we also work with mobile mapping. For example, highways, we have many kilometers of highways all over Europe. We have city inventories where we can mount a laser sensor to a car, drive along the city to detect all the assets around, like street signs, street lights, trees, also the streets themselves, or street markings are also common use case. Of course, on railways, this is also more and more common to mount laser scanners to a train and drive along the tracks to create a digital representation of the tracks. I will show more about that later on. And another common use case are power lines. So you can use either planes, helicopters, or drones to fly along power line paths to very precisely classify the pole positions and the wires, and then extract that as a 3D model and do some load analysis, for example, and yeah, really create a kind of digital representation of your point clouds or of your assets by that. And yeah, what we have done for some of those use cases is to train standard classifiers. So for like 3 of the use cases that we see here, airborne laser scans for the highways and city inventories, we have trained our own standard classifiers. So the pre-trained models that we can use as baseline models for our projects. And they really kickstart then a project. If we work on a project for airborne laser scans, for example, we can use this classifier to pre-classify data and then optimize that for a specific project and yeah, create a new optimized workflow for a new client or even a new use case which just has a similar data type. So it helps a lot to have some available models, which we also offer on the platform for all our users. But then within our projects, which I want to show now, we also train custom models for new use cases, and we add further analysis steps within that classification workflow to also extract features to create the final data products that our clients need. And to cover also a bit like the approach that we're using, it's and why we have this cloud platform for that. Within the cloud platform, we can cover the whole data science or AI model life cycle. So from the initial training data generation, which I've shown in the very beginning, we can do the manual classification to train or show the classifier how objects look like and how they should be classified. So that's just the beginning. We can then train the initial classifier, deploy it on the platform, and apply this model to new data. And when we see where we still need to optimize, we can correct any misclassifications of this initial classifier and iteratively retrain the model, deploy it again. And all of that is supported within the platform. And we can even then deploy the final model and apply it to very large scale data sets. So we have this kind of workflow which is really optimized for the use case 3D point cloud classification. We have a lot of freedom to customize parts of that pipeline, and by that we can do the projects very efficiently. Now to show some of the projects, and I want to start off with two projects that we did for the British Ordnance Survey. First one is a bit special. It's not even laser scanning, because I also wanted to show that the LiDAR sensors or laser scanners are not the only use case that can be covered. This data is photogrammetric. That means it's derived from 2D imagery. This is based on aerial images, which are then stitched together in a so-called photogrammetric process to identify 3D objects. It's a bit similar to what you see on Google Maps if you switch on the 3D mode, but this is rather the raw data, and we can also train AI models on that. So here we do not have so-called intensity values, but we can use the RGB values for training as well as any near-infrared if it's available, and also detect objects like the vegetation, building roofs. We have in yellow the roof clutter here, any objects on the roof, building facades, vehicles, and so on. So all of that is possible, and we can adapt our pipelines to work with any kind of input data that we have, as long as it's a 3D point cloud and we want to do the segmentation task. Second project with Ordnance Survey was for mobile mapping. So here was the goal to see how far can we get, how good accuracies can we reach with a medium-ranged laser scanner. So this is not a high-end model, but rather a mid-range one. And for this mobile mapping within the cities, we want to remove those kind of vehicle artifacts. We see all the yellow points here, which are caused by vehicles driving behind or in front of the scanning vehicle. So we want to remove that, clean the point cloud. We also want to detect parking vehicles, which can also be removed when, or we want to detect, of course, the assets in the street, like the street lights, signs, and further objects. Now about some of the airborne laser scan projects. So as I mentioned, the goal is to offer a scalable platform that really works with large data sets. So City of Munich was one of those projects where we classified more than 500 square kilometers. And you might know that within a large, big city, we have so many different kind of objects. So we need to do a very good selection of training data, try to show many different areas. For example, train stations are very, very complex. So we included some of those in the training data set. We included some construction sites to, because they also look different every time. And we try to make the model as robust as possible for even for the edge cases. So we do the training data selection, retrain the model based on our standard classifier, of course. So we do not start from zero for such a project, but we then add more edge cases in the training data set to make the model more robust. And once we have done that, we can apply the classifier to the whole data set. And in this case, like typically we tile the data set. We do not work with one 500 square kilometer file, but we do like 1 by 1 kilometer tiles. And we can then even parallelize the process. So we can run on 20, 50, 100 machines in parallel and process those files really fast. And it was less than 5 days of processing for like a data set that can reach several hundred gigabytes or even terabytes typically. And we did something very similar for the city of Helsinki, including some extra steps. So city of Helsinki is also regularly scanning the whole city with laser scans. So every couple of years, there's a new data set, often with different properties. So the point density increases, we get better quality data every time. The goal in the end for City of Helsinki is to do some vegetation analysis, for example. And we can see on the left side the initial screenshot of our standard classifier, which worked okay, but not great in the beginning. So there were some misclassified roofs. We had very high point density for this data set. So we just added a couple of training samples to optimize the classifier for this data set. And the final result looked really good in comparison. We reached much better accuracies, and we even added some more post-processing steps because that was something that this client was interested in. We wanted to separate low, medium, and high vegetation, and not just do it based on height above ground, but also on a cluster-based approach, so that we can have individual tree clusters and get the whole tree in one class instead of tiling it into 3 different segments. Based on height above ground. And we also added a water shapefile. So that's also one of the, let's say, learnings from previous projects. We do not only rely on the AI model, that is one part of a processing workflow, but we can also add either existing data, like we had a very good shapefile for the water bodies, which we can overlay onto the ground layer and use it here, or we can use rule-based corrections or sanity checks at the end to correct parts of common mistakes from the classifier. So that's also part of a workflow. And now I want to share a bit more about the project with Digital Rail Germany. Here we did 2 training iterations for us. It was a completely new use case. It was like data which is not really comparable to a highway scan or a city scan, very new environment. So we started with the training data generation. We were still able to do some pre-classification to classify vegetation and ground, but all the new classes needed to be added. And in the initial iteration, we trained on just a few basic classes like the rails, the catenary poles, overhead wires. And in the second iteration, we added more detailed classes to also identify the signals, some fuse boxes or signs along the tracks. And like this, we do this iterative training here as well, adding more edge cases, identifying like issues with the current version, and then adding more. Like also for railway tracks, we have very diverse environments. It can be in urban environments where we have a lot of buildings aside. We have tunnels, we have train stations of all sizes and types. So we need several iterations or a very good training data set in the end to cover all of those use cases and environmental changes to make the classifier work well. And once the classification is done, we can extract specific objects of that, and also this data is used for the creation of digital HD maps for also supporting autonomous driving on trains, for example. And here again, we also did some post-processing, which is more rule-based, for example, to correct misclassifications within the trees. So that can be done automatically. And you can also see that the rail has 2 colors here on the left. It's purple and blue. The AI classification was both of them, and we actually did a post-processing to just extract the top part of the rail because that is relevant for extracting a vector line or the exact position of a rail. So we first classify the whole rail as it is, and then do a post-processing to just extract the upper part of it. And in this very last part of the presentation, I also want to show a bit how this data can be used in the platform, or how the Pointy platform can assist this process. And I also want to show some more of the rail data, so we can upload all that data to the platform. It will be classified automatically, and then we can work with it. So we can, here in this project overview, we can see the different tiles. So as I mentioned, the data is always split into smaller parts. We can see some preview on the right. We can also see some metadata. For example, this file has 26 million points. And in this example, I want to add some classification. So we have our standard classes, but I now want to also classify some further classes. And as you can see, we can hide or show each individual class. We can hide the points or show them as we like. And all the white points here are unclassified, so those were not objects of interest in the first iteration. So now I'm doing a subselection to classify the vehicles in here. And as they are previously unclassified, we can now add some further classification manually. We can adapt the subselection dynamically. Even within the subselection, we can show or hide the different classes. So I'm hiding vegetation right now. I'm also locking the ground class. That was the second click I've done here. And now I can select the class vehicles, which I added previously. I can select the polygon, and because the ground is locked, I will not override it and only classify the remaining points on top. And just like that, we have classified the 3 cars and 2 bicycles, which are present here. And we have a quite clean classification because the ground was already pre-classified. And now we can hide or show the cars in here, and we could even remove the points on export. So we can do some dynamic cleaning. We can remove noise points or any points which are not interesting after export. So now you have seen this point cloud floating in black space. I also wanted to show that we can add some context by showing the base map. We have implemented OpenStreetMap as well as Open Railway Map, so we can switch to that. Open Railway Map shows also the stations and some connections, and we can also show satellite imagery to give even more contextual information. And the last video I want to show is about the vectorization. So the classification actually supports the vectorization approach in here. The 2 green lines for the rails are already vectorized, and I will add 2 more lines showing the process. So we can select the object that we want to add. I will draw a polyline, and now I will only display the rail points. So also the polyline will only be added or be available on the rail points. So now I can very quickly create the 2 new vectors in here, and showing that together with ground or the rails, or just showing the vectors is already the one output that we can export and use in other tools. So we can export that as GeoJSON and have some extracted rails based on the classification. And in the future, of course, this will also be automated. We have already done some pilots for that. But for now, we have the tools in the platform to do that manually as well. So that's the end of the presentation for now. I'm happy to answer any questions.
Yeah, thank you very much, Sid, for this good presentation, and I think also the feedback is quite positive for the moment. And indeed, there are questions for the moment, but it could be more for sure. We are good in time this webinar, and the first one is: what accuracies can be achieved by the AI models?
The accuracies, they of course depend on the complexity of a use case, and we do not reach accuracies as in 2D image analysis. So this technology is still quite new, and we need to learn how to work with it. But we can achieve accuracies like 95 to 97% at a maximum, depending on the class. But it's also important to understand that for the segmentation here, we not always need 100% to work with the data. For example, to do vegetation analysis, it's not important to have every single point. It's more important to not have large areas of misclassification and to know whether the model performs good or not so good. And then we can also add the rule-based corrections or checks later on to correct the areas automatically, which are important for our clients.
Yeah, the second question: how long does it take to develop a classifier for a new use case?
Yeah, if we want to develop a new classifier from scratch, like a completely new use case, like we did for the digital rail, it can take 3 to 4 months. But most of that part is firstly getting the requirements together. We need to define the classes that should be classified. We need to define what should be done with the data later on, so that we can also get the edge cases correctly and create the right training data. And then we need to do the training data generation, so the manual classification, and this actually takes the most of the time. And if we already have a good pre-classified model, we can reduce that time very much. Like once the training data, a high quality training data set is available, the initial training maybe takes around 1 week, and then we do iterations and enhance it over time. Oh, Lutz, I think you're muted.
Oh, could we use your point cloud technology at the wayside to scan the train clearance when train is passing like 60 kilometers per hour or even higher?
Doing clearance analysis is like a common use case for using point clouds. Like once we have the rails extracted, we can do or run a clearance profile on it and see if there is some vegetation growing in. But I must admit that the approach that we are using and the laser scanners that we are working with produce very big amounts of data, and we are not even close to real-time analysis here. So what we are doing is a kind of analysis once the point cloud was processed and registered. So that initially takes some time, and we work with a final point cloud and classifying, let's say 1 kilometer of railway that we have here might take even 20 minutes or something like that, depending on the point density. And of course, I mentioned we can parallelize this process for many point clouds, but it will still take too much time to do it in real time. For real-time analysis, one would need different approaches, like a lower density radar or LiDAR sensor, or maybe even use 2D images based on the use case. So a combination of those sensor types is probably the most sensible to have a good quality outcome for the real-time driving assistance.
Yeah. And again, great demo from the audience. Are data and labels loaded to the Pointly platform commercially protected or owned by the licensee, or does it use by Pointly for AI training classifications, e.g., commercialized for wider use on the platform?
If I get the question right, it's about the usage of the data that is uploaded, and it depends. Like we have our standard models, which we trained on data where we have the allowance to use the data, or we used open data sets or data from partners. But we also have a case where we train custom classifiers, such as for the digital rail. This is not a public classifier. This is a model which is only used by the digital rail. So both ways are possible.
Yeah. I have the question, an additional question to that platform. Is it also possible that data from other sources, from other companies, for instance, from satellite data on detection of the source of the contents of vegetation, could be integrated into the platform, or is it specially only for your data you produce with the sensors and so on?
The data source or the sensors can be very diverse. But it needs to be a 3D point cloud in the end. That's where we're focused on. And the 3D point cloud can also be produced by other technologies, not only LiDAR or the photogrammetry example that I showed, but it can also be satellite data that was pretty much like the same approach with the photogrammetry. That was where 3D models were derived, or it could be even sonar point clouds. So underwater point clouds can be created. It's different technologies, but as long as the point cloud is the output, we can work with it.
Yeah, and an additional question also has to do something with vegetation control. Have you ever been involved in vegetation measurement and level crossings? Which is the frequency of data refresh? I think it could be a separate question.
I'm not sure about the level crossing.
Yeah, in German is Baden-Würtern.
Okay.
Sure.
Yeah, it could be done by either some mobile mapping solution. There are also portable scanners, or as mentioned, the mobile mapping either mounted to the car or to the train. So as long as we have some 3D data for the around the level crossing, it can be analyzed. And vegetation is like a very typical thing to extract. So yeah, we have not worked directly on such a use case, but yeah, it's quite common one to do vegetation analysis and extraction. And the frequency of data refresh is really up to our clients. Like we do not produce the data ourselves, but we are rather enhancing it with required information to do the analysis. So as I mentioned, the city of Helsinki, for example, is creating scans every couple of years. For some use cases, it might be needed to do it monthly or even weekly. But as mentioned, we do not do the real-time processing, but rather one-time analysis for large data sets. That's like the typical approach at the moment. Other ones could also be feasible, of course.
Yeah, thank you very much. No further questions in the chat for the moment. If there is some additional question, please raise your hand and open your micro and ask directly. I will observe the yellow hand in the next minutes. And if it is not the case for the moment, I will take the chance to motivate you as participants to take only 2 minutes to fill in our short feedback questionnaire. It's on the quality of organization of the webinar and of the presentations for sure. And what is the most important, maybe you have some suggestions for future ERCI webinar topics. Please let us know, or maybe you are interested to present your innovative solution by yourself in one of our next ERCI webinars. Yeah, please let us know this too. The link to this form you can easily find in the chat. So I have to share my screen again, I guess. So then, yeah, you will find the recordings of the ERCI webinars at the YouTube platform of the former STARS project, and it might take some days in order the video is ready, and then you will find also the recording of this video in the chat. Before coming to news from the ERCI network, I want to raise your attention to the next ERCI webinars. There are two, and the first one is integrated into a wider approach. It's on innovating rail through international collaboration. That is a virtual conference and a B2B networking platform. The main organization is with the ERCI Partner Cluster Rail Forum and with Innovate UK, with strong support from ERCI and the Enterprise Europe Network. And the thing of registration is a bit different as usually. This link leads you to a B2B matchmaking platform, and it's needed that you have to install a small profile of you and your company, but how to do is very easy, and it's also described in this platform, so please do not shy to do so. And with this registration, you have also the possibility to follow the virtual conference on Wednesday, the 13th of November, on innovating rail through international collaboration, with contribution from ERCI. And you have also the chance to meet possible new partners, contacts, interesting to you and your business within the following 3 days. That means the afternoon of the 30th of November and all the day, the 14th and the 15th of November. So the virtual meeting slots will take about 20 minutes so that you have the time for first conversation with possible interesting partners. And please, when creating your profile, create it in a quite interesting and quite sexy way so that you can attract possible other participants to get in contact to you. So the webinar, there will be a webinar on the role of circular economy in the railway sector in 5 weeks on the 27th of November. And the registration link is already available and is also just available in the chat. So something about news from the ERCI network. Yeah, some follow-up from the InnoTrans. The ERCI was present at the InnoTrans with booth of 10 of its 18 member clusters. That means the majority of ERCI members were present at the InnoTrans, and we conducted and organized some interesting events, like panel discussions on the Leader 2030 project and presentations of other innovation projects. We also conducted ceremonies like the official signing of the ERCI membership agreement by our youngest ERCI member, PFP, the Portuguese railway platform. Then traditionally the ERCI Innovation Awarding ceremony this year together with the ERCI Achievement Awarding ceremony and the Women in Rail Award. For sure, these are examples. And we did some networking activities like meet and greet events, booth receptions, and the Women in Mobility Luncheon, also supported by ERCI. So I think in 2 years, in 2026, we would be present again during the InnoTrans, and in the next year, I'm sure that on the one and another trade fair show, you can see some ERCI members too, which are present at the fair. For instance, this year in the beginning of November, in 2 weeks in Barcelona, the Tomorrow Mobility and the Smart City Expo and World Congress, there will be present with 2 booths representing ERCI. It's the Berlin-Brandenburg booth and the booth from InMove by Railgroup. So, this slide is to invite you to think about to apply to the next ERCI Innovation Awards. The application phase starts in spring 2025, and it is a 2-stage application. The first stage is the regional stage. That means you have to apply by your regional ERCI member cluster, and then in the second stage, every ERCI member cluster can nominate up to 3 applications to the European contest. So, coming to one project which is led by the European Railway Clusters Initiative. It's a Europe's Rail project called Leader 2030, and I will hand over now to Guido Ancarani from DTEC Fair and Operations Director of ERCI to present some aspects of this project. Guido.
Thank you, Lutz. Yes, I will be short because time is running. We have this Leader 2030 project, which is funded by the Europe's Rail Joint Undertaking, and you will have all the news and more information on the links that you will find in the chat. It's a project in order to face and try to be resilient at European level for the railway research and development project, which are undergoing on the previous Shift to Rail and now Europe's Rail Joint Undertaking. Next slide. Yes. So what is the problem is that if we take a pen, we can see that the components and the raw material which are needed to manufacture a pencil are coming from 10 different countries. I will not list and read all of them, but you can understand that we are components are coming from worldwide. And is it a problem? Yes and no. Is it a problem also because there are questions linked to the sourcing and the supplies? Materials and the raw materials and components have to be transported. You can imagine already some of the difficulties we raised in the last years, and the lesson learned that we have faced in the last years bring us to be attentive also to the geopolitical factors in some areas. Unfortunately, there are wars ongoing, and climate change. Those are factors that will influence the future. And we try with this Leader 2030 to give some proposal and propose some solution and put the finger on the difficulties of the future in order to ensure the possible manufacturing of the research and development project which are ongoing. Next slide, please. So the Leader 2030 is a project which is led by ERCI. And as you know, ERCI is 18 clusters which are installed in 17 countries in Europe. So we are near the manufacturers, near those who are producing the product for the infrastructure or for the rolling stock or for the signaling in the future. And in addition to ERCI, the other main partners of this project are Railenium, the technological center in France, in Valenciennes, JKZ, which is a cluster in Saxony, focus on mining, and the Technopark Istanbul, who will help us with some knowledge they have acquired on other sectors, because as you can imagine, not only railway will need raw material and components. So with this partnership, we have defined 5 work packages. The first is the study of the past and that has been done, while in the meantime, work package 2 was analyzing the demand side, which means using the ERGU main document to understand what will be the future railway subsystem and product and components. And this has been done or is on the final stage. So we started now with the work package 3, which is the analysis of the supply side, going into the details of components and raw material in order to understand which are the needs of lithium, gallium, or whatever will be used in the future manufacturing of products and system. So this is what is the current situation and the involvement, in this case, of the JKZ partner, which is specialized in this topic. Next. So just to not to conclude, but to extract something which came out during InnoTrans, where we have been able to present some of the partial result of Leader 2030 and participating to very interesting roundtable. We just have highlighted the 2 points, which are complementary in a certain way to what we have done or what we are doing in Leader 2030, is about additive manufacturing, because this is another potential solution for satisfying the possibility of manufacturing in the future, and the use of composites. This means not focusing on the classical raw material that we can imagine that are needed, but also other raw material and the composite themselves. So just to give you some idea of what we are doing, where we are oriented, and what could be some of the elements in the recommendation for the Europe's Rail Joint Undertaking. Certainly, those are just examples. If you want to add something and contribute, we will be glad to discuss with you, because it's all together that we have to face this difficulty of resilience of the future. And be ready, let's say, around 2030, when the manufacturing question will be on the table, because the different research and development and innovation project will arrive to TRL 9, technological readiness level, which means ready for manufacturing. Thank you.
Yeah, thank you, Guido, for this overview on the current status of the Leader 2030 project. And you are invited to contribute if you have certain issues with supply chain gaps of raw materials as well. Yeah, one short hint to the former success project. The success project is already closed, but the activities are still ongoing to support European SMEs of the rail supply industry in successfully applying to public procurements outside Europe, especially in USA, Canada, and Norway outside the European Union. And if you are interested in these countries, please contact ERCI. There are 3 ladies from the project consortium from DTEC Fair, from eTrans in France, and from MAFEX in Spain, which are able to assist you if you, as a company, are thinking about applying to public procurements in these 3 countries. So the last slide is very thank you to all of the participants for your attention to this webinar, and second, encouraging to use our short feedback questionnaire to give us some hints on future ERCI webinars. Thank you very much, and see you soon, maybe on 13th of November or on the 27th of November or on both dates. Have a nice day. Bye-bye.